In this video, I want to remind you that NLP area is not only about mathematics, but it's also about linguistics, and it is really important to remember it. So the first slide would be about this picture that is really very popular in many introductions to NLP, but I think that we also need to briefly cover it. So let us say that we are given some sentence. There are different stages of analysis for that sentence. The first stage, which is called morphological stage, would be about different forms of words. For example, we care about part of speech, text, we care about different cases and genders and tenses. So this is everything that goes just for single words in the sentence. Then the next stage, syntactical analysis, will be about different relations between words in the sentence. For example, we can know that there are some objects and subjects, and so on. Now, the next stage, once we know some syntactic structures, would be about semantics. So semantics is about the meaning. So you see, we are going higher and higher in our abstraction, going from just some symbols to some meanings. And the paradigmatics would be the highest level of this abstraction. Now, one reason why we do not cover all these building blocks in many details later in our course is that you can just use some very nice black box implementations for low-level stages. For example, for morphological and syntactical analysis, you might try using NLTK library, which is a really convenient tool in Python. So please feel free to investigate it. And another thing that I wanted to mention is Stanford parser. It is a parser for syntactic analysis that provides different options and has really lots of different models built in. Now, Gensim and Mallet would be about more high-level abstractions. For example, you can do some classification problems there, or you can think about semantics. So you have their topic models and some word embeddings representations that we will discuss later in week 3. Now, another thing which also comes from linguistic part of our area is different types of relations between the words. And linguists know really a lot about what could be that types. And this knowledge can be found in some extrinsic resources. For example, WordNet is a resource that tells you that there are, for example, some hierarchical relationships. Like we have some fruits and then some particular types of fruits, like peach, apple, orange, and so on. So this relation would be called hyponym and hyperonym. And there are also some other relationships, like part and the whole. For example, you have a wheel and a car. So this type of relationship is called meronyms. Now, this type of relationships can be found in the WordNet resource. Here in the slide, I have the picture of another resource, BabbleNet. The BabbleNet resource is multilingual, so you can find some concepts in different languages there. And what is nice, you have some relations between these concepts. So, for example, I just typed in NLP there, and then I have seen part of speech tagging task. I clicked into these tasks, and I could see some nearest neighbors in this space of concepts. For example, I can see that Viterbi algorithm and Baum-Welsh algorithm are somewhere close by. And after week 2 of our course, you will know that they are indeed very related to this task. So the takeaway from this slide would be to remember that there are some extrinsic resources that can be nicely used in our applications. For example, how can they be used? This is a rather complicated task. It is called reasoning, and it says that there is some story in a natural language. For example, Mary got the football, she went to the kitchen, she left the ball there. Okay? So we have some story. And now we have a question after this story. Where is the football now? So to answer this question, the machine needs to somehow understand something, right? And the way that we can build this system would be based on deep learning. So you might have heard about LSTM networks. It is a particular type of recurrent neural networks. But here, you see that you have not only the sequential transition edges in your data representation, but you have also some other edges. Those red edges tell you about coreference. Coreference is another linguistic type of relation between the words that says like, she is the same as Mary, right? So she is just a substitute for the Mary. And for example, this and that football is the same ball, just mentioned twice. And the green thing is about hyperonym relationship that I have briefly mentioned. So the football is a particular type of the balls, right? So once we know that our words have some relationships, we can add some additional edges to our data structure. And after that, we can have so-called DAG LSTM, which is Dynamic Acyclic Graph LSTM, that will try to utilize these edges. Okay? So I'm not going now to cover this DAG LSTM model. I just want you to see that there is a way to use the linguistic knowledge to our needs here and improve the performance of some particular question answering task, for example. In the rest of the video, I want to cover another example of linguistic information used in the system. So this will be about syntax. So let us have just a few more details of how syntax can be represented. Usually these are some kinds of trees. So here you can see the dependency tree, and it says that, for example, the word shot is the main word here, and it has the subject, I, and the object, elephant, and the elephant has a modifier, n, and so on, right? So you have some dependencies between the words. And usually you can obtain this by some syntactic parsers. Another way to represent syntax would be so-called consistency trees. So you can see the same sentence in the bottom of the slide, and then you parse it from bottom to top to get this hierarchical structure. So you know that n and elephant are determinant and noun, respectively, and then you merge them to get a noun phrase. After that, you merge it with a verb, which is short, and get a verb phrase. You merge it with another subtree and get a big verb phrase. And finally, this verb phrase plus noun phrase, I, give you the whole sentence. Actually, you can stop at some moment, so you can not parse the whole structure from bottom to the top, but just say that it is enough for you to know that, for example, in my pajamas is some particular subtree. Why can it be useful? So first, it is called shallow parsing, and it is used, for example, in named entities recognition, because a named entity is very likely to be a noun phrase just altogether, right? Some New York City would be a nice noun phrase in some sentence. So it can help there, but it can also help as the whole tree in some other tasks. And the example of some of this task would be sentiment analysis. The sentiment analysis treats reviews as some pieces of text and tries to predict whether they are positive or negative, or maybe neutral. So here you can see that you have some pluses and minuses and zeros, which stand for the sentiment. So you have your sentence, right? And then you try to parse it with your syntax. So you get these nice subtrees that we have just seen in the previous slide. And the idea is that if you know the sentiment of some particular words, for example, you know that humor is good, then you can try to merge those sentiments to produce the sentiment of the whole phrase. Okay, so intelligent humor are both good and they give you some good sentiment, but then when you have some not in the sentence, you get the not good sentiment, which results in the negative sentiment for the whole sentence. So this is rather advanced approach. It is called recursive neural networks or dynamic acyclic graph neural networks and so on. Sometimes they can be useful, but in many practical cases, it is just enough to do some more simple classification for your words. So in the rest of this week, my colleague will discuss classification task, for example, for sentiment analysis in many, many details.